This is basic training covering spacesuit usage and mission management. Hello, my name is Ada, Artificial Intelligence Training Assistant. Welcome to Astropticon Training Center. Let's get you through your basic training. First, the flight controls. Hold the assign button to move left. Hold the assign button to move right. Hold the assign button to move up. Hold the assign button to move down. Hold the assign button to move forward. Hold the assign button to move backward. Hold the assign button to slow down and stop. Hold the assign button and move mouse to look away from current direction. Hold assigned button to rotate left. Hold assigned button to rotate. Good. Your A1 license is now granted. Let's continue with the training. Note that you have some active elements on your hood. On top of the screen, you will find conversation history. Open it now. That's it. This panel also. Now open the Objectives panel on the left of your HUD. This panel shows your current mission objectives, but will also show useful hints. Use it whenever you need advice what to do next. Now look on the right side of your HUD. You will find your current suit resource levels here, but also your flashlight setting control. This flashlight is very powerful as it's meant not only to help you work, but also find your way in the dark if necessary. On higher settings, it will drain your energy faster. Now let's get familiar with your workplace at the shuttle. First, approach the service station. To replenish your suit resources, simply point on service station with your cursor and hold the assigned button until they are fully replenished. Resources are free during training, but on a mission, you will be charged for using service station. Since we're already in the cargo bay, let's practice door control. You never know when it comes in handy. Cargo bay doors can be opened from both inside and outside. Let's close left hangar gate from the inside. Good. If you happen to be outside of shuttle and need tube and cargo bay doors, there's an external lever as well. Let's try it now to open the left hangar gate again. It's good to remember about these external levers. In the meantime, we're granting you a 2 license. Good. That covers your A2 license. Now let's get started with mission and resource management. Go to your hub screen and click on it with the assigned button. This training covers basics of performing repairs. Welcome back to Astropticon Training Center. Today we will go through basics of maintenance work. There are training sets prepared for each course. You will find everything you need under panel TG1. Go there now. Approach to the panel. It is marked on your HUD. If you're at a moderate distance from an object, you can view object name by pointing at it with your cursor. At larger distances, information will be displayed on blue background, but when you're close enough to interact with object, indication will be shown in green. While interacting with object, you cannot move, but you can still look around. You can also zoom in for more closer look using assign buttons. Let's open the panel now. You will have to remove all screws holding it with your screwdriver. Now move your cursor over the screwdriver. Now point on every screw and press the assign button. Good. With all screws removed, you can now remove the cover itself. To pull an object out of its place, drag your mouse. Usually, it's necessary to close a valve before you detach a pipe. In this training set, there is nothing flowing through the pipes, so there is no leak risk, and valves are only being closed as part of exercise. Close valves TSV1, TSV2, and TSV3 now. Hold the Assign button to bring up your toolbox again and select Wrench. Use your wrench to detach everything blocking your way to broken pipe. If something is attached with bolts, you need to remove them first. Simply point at them one by one and press the Assign button. Good. Now let's put all the parts back inside. You can find them in your Quick Inventory panel at the bottom of your screen. Clicking on Title bar of that panel will show or hide it. Remember to put the bolts back in. These are not in your Quick Inventory. For convenience, such small objects are always in your pockets, and all you have to do is to use wrench or screwdriver in the right place. Remember, because mechanics often forget to open valves after completing their tasks, it has recently become a mandatory part of this exercise. Open all valves now. Now let's open electric box TRB1. You will need to detach screws first. There is a single PLC controller here. It has no program loaded, so it does not perform any function, but it has power. Now detach battery TBT1 next to electric box. Look at PLC controller again. It has no power. Put the battery back in place. Some controllers have old firmware and do not switch on automatically after power has been restored. They have to be reset manually. Press the reset switch on PLC controller. Sometimes during repairs, you will need to remove or disconnect power source. It is your responsibility to restore entire object to its working state, so you may need to reset some controllers after finishing repairs. Now close electric box. We're done here. Don't forget to put back the panel and secure it with screws. Exit insertion mode by choosing Fly Away from your toolbox. Your M1 license has been granted. Congratulations. Feel free to practice and experiment. Once you're ready to move on, finalize this mission and choose another from Hub. This training covers using your palm top to diagnose problems and working with diagrams. Welcome to your first diagnostics training. A lot of new and interesting knowledge in this one, so let's not waste any time and fly straight for panel TG3. Approach to the panel. It is marked on your HUD. Let's try learning how pumps work and how can they be diagnosed. Before you start working with any set, it's usually a good idea to download its diagram. You do that using your palm top. Select If Now from Tools menu. You can operate your palm top by clicking on its screen or by using the assigned buttons. Select Scan QR Code, option in your palm top's main menu. Good. Your scanner is now ready to go. Do you see that label at the back? Scanning a code downloads diagram associated with given set and displays in on your HUD. Close this diagram for now. Once you have a diagram scanned, you can display it again anytime you want using the assigned button. Do it now. Good. You can reconfigure the behavior and control options anytime you want. By default, you need to hold the assigned button to show diagram. But if you prefer toggling, you can set it up like that. Let's scan the label on electric box TST EB1 now. Diagrams of electric boxes usually show objects controlled by that box. For example, on this diagram you can see that pump TSTP is connected to port PM1 inside electric box. This port is connected to port A3 of programmable logic controller TST-EP. This means that our pump is controlled by this PLC. Let's open this electric box and switch off this TST-EP controller. To switch off controller, you simply need to press the reset button on the front side of the controller. The pump will stop working now. Look at the front panel of this pump. There is a label there. Can you see it? Use your palm top and scan that QR code. When you scan any mechanical part, your palm top will give you live information about that part's state. While still in this screen, reset PLC controller TST-EP. Device will need about 2 seconds to start up. Electric motor has power again. This means our pump has also started working again. You can scan it if you want, but we will move to next section of this training now. Now scan pipe TST2. Every pipe has 2 sets of sensors inside, 1 at each end. When you see a difference in readings between beginning and end of pipe, it may indicate a problem with that pipe. Space is an extreme environment, and sometimes a liquid can freeze at some point in pipe, blocking it partially or even completely. Now scan pipe TST1, the fragment with valve on it. See what happens when you close the valve. As you can see, pump is still trying to push substance, so we get pressure reading on one end but no flow. Now open the valve again and observe values on your pump. Let's look at the antenna TS. Now open blueprint of electric box TST EB1 again. Scan the QR code on box cover or inside the box if you have to. Let's talk about antennas for a moment. This will help you understand how to interpret diagrams. First of all, antennas transmit and receive signals. This antenna is providing received signal to port ARC. This signal is then passed to port A3 of controller TSTA-TR. This controller is converting received signal to data. Data is then sent to ship's computer by data cable leading to port RS3. When SHIP's computer wants to send some data, it uses the same RS3 port, which goes to TSDATR controller. Controller will convert this data stream to antenna signal and output this signal on port A2. From port A2, signal goes to port ATR of our antenna and is being transmitted. But that's not all. Many antennas need to aim towards their targets, and they usually have two motors controlling their arm. SHIP's computer has all the navigation and positioning data required to do the calculations of arm angles. It requests certain arm angles by sending data through ports RS1 and RS2. These ports provide information to PLC controllers TSTAM1 and TSTAM2. Each one controls a single antenna arm motor. Whenever PLC wants to change angle, it will send positive or negative voltage to electric motor controlling that arm. But it also needs to know current position of arm to determine which way to turn. This is why each motor has two signals associated with it, controlling signal and sensor signal. Controlling signal is generated by PLC and sensor signal is generated by motor and read by PLC. You can play around and switch off PLC controlling antenna, but this concludes our basic diagnostics training. Remember to leave everything in working state. Otherwise, someone else will have to come here and fix test setup before next training session, and we will have to charge you extra in penalties for that. Your D1 license is now granted. May it serve you well. This training covers basics of repairing and trading. Back to the training center for more. Today we will show you how to actually replace broken parts. We will be working on more advanced set this time with active pumps and substances running through pipes. You will actually have to close valves before detaching pipes. Keep that in mind. No one is going to remind you about these kind of things during real missions. Approach to the panel. It is marked on your HUD. Now detach middle segment of pipe TPM10. You forgot to close the valve before detaching pipe. Close it now. Detach middle segment of pipe TPM20. You have both pipes. You can buy replacements or repair them in your hub, so go there now. we will buy replacement for pipe TPM10. Go to Inventory and in there to Trade Items page. Search for pipe with 100 centimeters length and 20 centimeters radius in Shuttle Inventory on the right and buy it. To buy or sell an item, while moving it to the left will sell items. We will not buy replacement for pipe TMP20. We will repair it. Go to your items page. We will need aluminum, rubber, and steel to repair this pipe. Go to Trade Resources page. Similar to item trading, you should select resources you want and use Trade Slider to transfer them between your inventory and shuttle reserves. You will need at least 40 G of aluminium, 5 G of rubber, and 100 G of steel to repair pipe. Purchase these resources now. Now go to your items page where you can repair pipe. Select damaged pipe and repair it. It's the 100 centimeters long pipe with 10 centimeters. Put both pipes back in place. Don't forget to put back the panel and secure it with screws. Aren't you forgetting something? The valves. You should have remembered to open them before closing cover. We intentionally do not remit about it during this exercise. Open them now. Approach to the panel. It is marked on your HUD. Good. You are now granted your M2 license. Using infrared camera to locate anomalies and diagnose problems. Welcome to Level 2 Diagnostics Training. Today, we will talk about thermal imaging, which is useful in many situations. Approach to the panel. It is marked on your HUD. Pick up infrared camera from your toolbox. Infrared camera has 3 basic operation modes with configurable settings. You can use buttons on the camera to switch modes and adjust parameters. To switch mode, you can press M1 button on your infrared camera. For now, this is the basic mode of operation. Camera will show temperatures within configured range. Temperatures that are outside of this range will be displayed in blue for colds or white for hot. So if you're seeing too much blue or not enough blue, you should alter minimum range setting by holding L1 or L2 buttons on your camera. And if you're seeing too much white or not enough, then you should alter maximum range setting using R1 or R2 buttons on your camera. Feel free to play around and adjust settings so you get a good picture. Let's play around a little close valve TSTV now. Now watch pump and pipes. You will see they get cooler as there is no flow in them. Of course, valve is not the only thing that can stop flow. A blocked pipe can do the same. So infrared camera can help you locate blocked pipes simply by looking for point on pipe where there's a sudden temperature drop. Have a look at electric box TST EB1. Note that you can see that devices inside it have power since you can see the heat on the cover. This does not necessarily mean that devices work as expected, but at least we know there's no issue with power supply. Let's look at other modes. Press M1 button on your infrared camera to switch to reference mode. This mode is useful when you're looking for specific temperature range. You can set the desired reference temperature, and everything that has this temperature will be painted white, while things that differ from the reference value will be colored differently until they fall out of range defined by margin setting. Everything cooler or hotter by that margin or more will be painted blue. Feel free to play around with settings and switch to FOV setting mode whenever you're ready. This mode is not actually an operating mode of camera in strict sense. Image displayed will be the same as in fixed range mode, but on this screen, you can only regulate camera's field of view using L1 or L2 buttons on your camera. When you're ready, switch to measure mode. Measure mode has no settings. It simply gives you exact temperature value measured at the center of screen. This is useful when you want precise reading. That's about it. Infrared camera may not be necessary to diagnose problems and may not provide decisive information, but it's certainly a useful tool to narrow problems down quickly. That's why most mechanics like to keep it handy for time-sensitive encounters. Batteries have failed, check them and replace them with new ones. The satellite reported error PE21. As you know very well from the manual, this means that its battery has failed and disabled important systems. Replace it and turn on all systems. Another day means another problem. Today something clogged the pipes. Nothing flows through the pump. Check it out. using multimeter to diagnose electric devices. Welcome to your advanced diagnostics training. Approach to the panel. It is marked on your HUD. Before we begin, scan QR code on TST EB1 box cover to get a diagram. Good. Now open the box. We will do measurements and learn more about various signals in our current training set. Many of them are standard signals you will find on most other objects. Select Multimeter from your Tools menu now. Multimeter has 4 different modes. We will start with DC mode, which means direct current mode. Click on Handle on the left side of meter or press the assigned buttons to select DC mode. Direct current means constant signal, such as power supply, slowly changing control signals, etc. These signals have no frequency and no shape. They're just voltages. Measure port P plus of controller TST-AM1 by pointing at it and holding the assigned button. Standard voltage should be 12V. Now measure port P minus. You should see 0V here. When controller isn't starting up, you should always start by checking if it has power. If power is there but controller does not respond to reset switch, you will know it's the controller that is faulty. Of course, there may be other reasons why PLC is not fulfilling its function, but lack of power and faulty device are the only reasons why it would be completely irresponsive. Now measure port A2 and observe it for a while. Note that while most of the time it shows 0V, from time to time it puts out 12V or 12V. That's because this is a signal controlling antenna arm motor. Look at the diagram now using the assigned button. Now try measuring port A3 of controller TST-AM1. This one shows 0V because it's an alternating current, meaning it has either a sine or square shape and a certain frequency. Since the signal is oscillating, its average value is 0V, and that's what the meter will show. Now switch multimeter to AC mode and try measuring port A3 again. Now we can see 12V of alternating current. Let's have a quick look at our diagram to see what kind of signal this is. As you can see, port A3 of controller TST-AM1 is connected to port AM2 in the box. Now look at antenna symbol. Port AM2 is the sensor signal from antenna motor. This is why knowing how to read diagrams is important. Following the trail is the bread and butter of any diagnostic task. Close the diagram and let's go back to measuring. Let's try measuring port P plus again, but this time in AC. As you can see, we get 0V on power supply of our controller. This is because power supply is constant voltage, so multimeter is not detecting any amplitude here. You always need to use DC mode for constant voltage and AC mode for dynamic signals. Otherwise, you will get wrong reading. You would be surprised how many space mechanics keep making this particular mistake, so stay sharp. Let's go back to our port A3 again. Keep measuring it using AC mode and see if there is any change when you hear antenna rotating. Nothing, right? It just keeps showing 12V. That's because antennas need to be angled very precisely, and using voltage to encode information from motor sensor is a bad idea. Voltage value is too susceptible to interference and cannot be used to pass precise values. We instead use frequency of signal to encode values. Switch to Hertz mode now. And now let's repeat our measurement. Hold your probe at port A3 and listen to antenna motors. See how value keeps going up and down when antenna angle changes. Now let's see if you can read diagram correctly. Solve this quiz. Feel free to bring up scanned blueprint as many times as you want using the assigned button. I think you deserve a little reward. Switch your multimeter to oscilloscope mode. Now check signal at port A2 of PLC controller TST-ATR. This is the signal sent to antenna to be transmitted. It's a sine wave because sine waves are the standard choice for long-range transmissions. As you can see, frequency keeps changing. That's our encoded data. You will see something similar on a 3-port receiving signal from antenna. Now let's measure port A, 3 of controller TST-AM1. It's the one used to receive signal from antenna motor position sensor. As you can see, this one is not a sine, but a square. This is because square signals give a very sharp frequency reading. They may not be as good for transmitting wirelessly, but they're very good for precise data sent locally by wire. I hope you will remember today's lessons. This is the most advanced diagnostics license you can get and requires proficiency with diagrams. If you do not read diagrams carefully, you are very likely to make simple mistakes like using DC mode to measure AC signal or measuring the correct port, but on the wrong controller. Always double-check yourself and don't let confusion get the best of you. That's it. Feel free to play around and measure things. Don't forget to clean up when you're done. At this level of expertise, you would have no excuse. Your Level 3 diagnostics license has been granted. Congratulations, my friend, and welcome to the big league. There is no power in one box check if the battery has failed. If so, replace it and reset all. Here we go again. Something is wrong with these pipes because every now and then they leak. This is the 16th repair of this satellite. Locate the leak and try to fix it. Working with electric switches. Welcome to your basic electronics training. Approach to the panel. It is marked on your HUD. First of all, scan QR code on TRE2 box cover so we can get its diagram. Let's see what we can learn here. There's one PLC controller and a lot of switches. Controller has 3 ports with cables connected to them: B1, B2, and B3. We can also see that there are 4 lights connected to ports: L1, L2, L3, and L4. Lights don't produce electric signals, so this means that B1, B2, and B3 on controller should be output ports controlling these lights and not input ports receiving signals from somewhere. Good, now open the box. Let's see what kind of signals is that PLC controller producing. Measure ports B1, B2, and B3 with DC mode of your multimeter. Do at least 3 seconds of continuous measuring with each one. Alright, it seems that port B1 is always giving 12V. Port B2 is flashing slowly and port B3 is flashing fast. We will not be needing multimeter anymore, so you may put it away. Let's talk about triple breakers now. There are 2 of them here, LBS1 and LBS2. Open up diagram and look for their symbols. Breakers are pretty much switches. They have 3 ports on each side and a switch between them. There are no dedicated input and output ports. These breakers work both ways. Close the diagram and let's look at breaker LBS1. Look at the markings on switches. They're very easy to read. When switch is off, red markings will be visible, and when it's on, green markings. Let's flip all the switches on LBS1 until we see green markings on them. Otherwise, signals from PLC controller L1 aren't going anywhere. To flip one of these switches, simply point at them and click. Good, now let's look at the diagram again. There's another kind of switch here. Look at the symbol of LMS4. It's a multi-state switch, connecting port B with one of its A ports. This is also a switch, so it has no input or output direction. It can be used as selector or as redirector of electric signal. Let's close diagram now and turn switch LMS4 into position A2. Good. Now that constant 12V signal from port B1 on PLC controller is passing through breaker LBS1 into port A4 of our multi-state switch. This port is now passed to port B and from there straight to light TL4. Let's have a quick look at the diagram again. That's the connection we just made, from port B1 through switches, LBS1 and LMS4 to port L4 and straight to light TL4. It's time for a test. Let's see if you can make light be turned on permanently. Light TL2 to flash slow and light TL3 to flash fast. If you don't remember which PLC ports have slow and fast flashing signals, use your multimeter to check. If you don't know which port powers which light, have a look at diagram. Good luck. Nice job. Now one more test. Set everything up so that all lights permanently switched on. Looks like you can handle reconfiguring electric circuits. You are hereby granted E1 license. Congratulations and good luck with your future assignments. transport drone went offline. We believe it's because one of solar arrays is faulty and battery charge no longer works. We had problems with solar array SA1 on this drone recently. We want you to go there and switch charge mode to working solar array SA2 using switch SE1. Also, to make sure no one will switch mode back to solar array SA1 or combined mode SA12, we want you to permanently disable these modes by cutting them off using breaker SE2. Once that's done, reset all PLC controllers to bring drone back to life. During the scanning of the atmosphere, one battery was damaged. Replace it so we can complete the measurements. Our transport drone reported problems with battery before we lost communication with it. Approach the drone, take out battery and repair it. Once you place the battery back, you need to reset all PLC controllers in the drone, as they do not restart automatically after power loss. You should find all parts of interest under panels EP1 and EP2 of the transport drone. Good luck. Something is leaking. Check if it is not a pipe. working with electric cables and detaching devices. Welcome back. Today we're getting more serious and we will be repairing a programmable logic controller. Let's head to panel TG1. Approach to the panel. It is marked on your HUD. This set is simple, so we will not be working with diagrams. Just open box TRB1. Look at controller TMC1. It's not working. Let's try switching it on. Press reset switch on this controller. Nothing. So first thing we do is check if TMC1 has power. Grab your multimeter and test it. I will not give you any hints. Looks like it has power, so there's obviously something wrong with PLC itself. We will have to repair it, but of course first we need to disconnect cables. Let's start with the easy one, the DC1 cable. All you have to do to pull the plug out is to hold and drag the assigned button. Good. Now have a closer look at other ports, where cables are connected. You will notice each port has a small screw that holds the... Once you unlocked all 3 ports, pull cables out by dragging them. That's it. Now you can just detach go back to your hub and repair it. You may need to buy some resources. Nice job. Now put TMC1 controller back in place. Time to connect all cables back it. Let's start with DC1 again. To put cable back in, you first need to grab the plug by clicking on it and then clicking on the port. And now the cables PP2 and PN2, but don't connect cable LC1 yet. Good. That should provide power to controller TMC1. Reset it now. It's working. Before we connect cable LC1 back to port A3, why don't you measure that port and see what kind of values it generates? Do at least 3 seconds of continuous measurement. The signal seems to be constantly present, but changing its voltage. Let's put cable LC1 back to port A3. It will pass this voltage to that long light TSL1 next to electric box. It works. Enjoy the show and don't forget to close the box and panel once you're ready to leave. Your E2 license is now granted.